Hi guys, this is Hayati. Welcome to A-Level Mathematics Online. In this video, we are going to cover composite algebraic functions. In the previous video, we did simple algebraic functions, and now we are going to differentiate composite algebraic functions. So first of all, we need to understand how the composite algebraic functions looks like. You need to identify them, and then we can only differentiate them. So we need to understand how composite algebraic function looks like. So let's take an example. Let's say I have an x and then I multiply any number to this x. Let's say I multiply a 3 to it. It becomes 3x. But this again is a simple algebraic function. What if I add some number, some constant, let's say I add 7 to it? This again is a simple algebraic function. But what if I make a bracket here and add some power to it, to whole of this function? Let's say I add a cube to it. So now this is a perfect example of composite algebraic function. So how we are going to deal this? First of all, you are going to follow the same rule. You need to make a d over dx. Why x? Because the function the variable involved in this function is x. So we are going to differentiate this. So now you need to follow me how exactly we can differentiate composite algebraic functions. So you need to bring this power. You need to multiply this power with the whole function. So 3, we need to bring this power here. 3 multiplied by 3x plus 7, and the original power was 3, and then we need to subtract a 1 from it, and then after doing the whole bracket thing, you need to get into the bracket as well. So you need to multiply it by the differentiation of the bracket as well. So what is the differentiation of 3x plus 7? d over dx. So d over dx of 3x plus 7, d over dx of 3x is 3. Because I told you any variable with power 1, the differentiation is 1. So the differentiation of 3x will be 3. The differentiation of 1x is 1, so the differentiation of 3x is 3. And the differentiation of 7 is 0. So the answer is 3. So we need to multiply this by 3. So this would become 9 into 3x plus 7 to the power 2. So the answer is 9 into 3x plus 7 to the power 2. This is how composite algebraic function looks like and how we differentiate it. And we are not going to stop here. We are having some more examples to clear. So you need to stick around and watch the complete video to understand how exactly we are going to tackle the questions. So this would make your concept crystal clear. So now another example. Let's say we have example square root of 1 minus 3x. Now you need to understand why this example comes under the topic composite algebraic functions. Because if we make this function, if we simplify this function, it looks like 1 minus 3x to the whole power half. And this is exactly like the previous example, because we had a simple algebraic function and we took a whole power to it. So we are going to differentiate this. So we need to write d over dx, and then we can start the question. So you can bring this power here. This would become half 1 minus 3x to the power half and then you can subtract a 1 from it. So this was the outer differentiation. Now we are going to differentiate the inside function, that is 1 minus 3x. So the differentiation of 1 minus 3x is, we can do it here. The differentiation of 1 minus 3x is, the differentiation of 1 is 0 because the constant do not changes, so we are not going to write anything there. And the differentiation of minus 3x will be minus 3, and the differentiation of x to the power 1 is 1, so we are going to get a minus 3 there. So we are going to multiply a minus 3 here, and this would become minus 3 over 2 into 1 minus 3x to the power minus half, and this would become minus 3 over 2. We are going to bring this whole bracket in denominator to make the power positive, and this would become minus 3 over 2 1 minus 3x, and this is the final answer. So we have another example of a composite algebraic function. So let's take it. 1 minus x plus x square. So this is basically a simple algebraic function. Basically there are some terms which are adding and subtracting together and making up a simple algebraic function. So if we add a power to it, this actually became a composite algebraic function. So we are going to differentiate this. So first we need to write d over dx, and then we are going to differentiate this. We need to bring this 8, we need to multiply this 8 with the rest of the function, and then we need to subtract a 1 from the power, and after that we are going to differentiate the inner bracket, which is 1 minus x plus x square. Differentiation of 1 would be 0. Differentiation of minus x would be minus 1, because the differentiation of x is 1 and differentiation of minus x will be minus 1, and then the differentiation of x square will be 2x. So this is minus 1 plus 2x. So we need to multiply this by this bracket. The final answer would be, we can multiply this 8 with this bracket, so it would become minus 8 plus 16x into 1 minus x plus x square to the power 7. Now students, we have another example, x minus 1 over x to the power cube. So first of all we need to write d over dx here, and then we need to bring this 3 to the left, so it would become 3 multiplied by x minus 1 over x, and then subtract a 1 from the power, so this would become 3 minus 1, and then we are going to differentiate the inner bracket. So d over dx of x minus d over dx of 1 over x. So we are going to differentiate it. So the differentiation of x to the power 1 is simply 1, and the differentiation of 1 over x, we are going to do that. First we need to simplify the function, so we are going to write d over dx again, and then this would become x to the power minus 1. And now we are going to differentiate. We are going to bring this minus 1 to the left, so this would become minus 1 multiplied by x, and then we are going to subtract a 1 from the power, that would become minus 2. So now the final answer is 1 plus 1 over x square. So we are going to multiply this 1 plus 1 over x square with this function. So the final answer would be, we are going to multiply this 3 with this bracket, So this would become x minus 1 over x to the whole square, and then this would become 3 plus 3 over x square. So this was the final answer. So students, we are done with composite algebraic functions, and now you can differentiate simple algebraic functions as well as composite algebraic functions. And now we are going to move to another concept which is included in differentiation. So stay tuned.